Hey folks, so this is the second of two videos on solving linear systems using the elimination method. So if you have not visited the first video, this is not the place to start. So you may have asked yourself, well, what the heck, in all the examples that we've seen so far, the variables have been able to eliminate easily because they always had the same coefficient. And so what I'm going to talk about today in the second video is what the heck are you going to do if the variables don't have the same coefficient? So let's take a look at this example. So in this one, it clearly says solve by elimination, which means that I cannot use substitution. And so when I look at this, I can see that, I have 4x and I have x, not the same coefficient. I have negative 2y and I have y, 1y, not the same coefficient. So if I'm solving by elimination, I can't do that straight up. This is what you need to do. You have to multiply one or both of the equations so that there are matching coefficients for one variable. So that is the first thing that we need to do. So when I look at this, the first thing that I see is that equation number 2 has made this pretty easy for me. I could easily multiply either this equation by 4 or by negative 2 or by 2 or by negative 4 in order to make this work. I'm going to choose 4. And notice that when I do that I'm going to have a new coefficient for each of my variables. I'm going to rewrite that equation. So what I've done is I've taken equation number 2 and I've just multiplied it by 4. So I'm going to write that out just to keep me organized. But my new equation, when I multiply that 4 into every part of that equation, I end up with 4x plus 4y equals 24. Now, how is that useful to me? Well, you'll remember that the coefficient for my equation number 1, for the x variable, was 4. And so now I'm set up pretty sweet because I'm going to go ahead and write that out. So I have 4x minus 2y equals 6. And so now I've created a situation where I have my x variable that can be easily eliminated out, and then it's business as usual. So keep in mind I've done the same things as before. I've aligned my variables right underneath one another, and on the same side of the equation I've aligned my constants on the same side of the equation, and so now I am good to go. And we saw in the first little blurb that I said about how no matter if I take an equation and I multiply it by any constant value, then any ordered pairs that satisfied the original equation will still satisfy our new equation as well. That's an allowable thing to do. So now I'm just simply going to go about my business of eliminating my x, and I can do that easily by subtracting. So 4x, take away 4x will leave me with 0x, of course. Now I need to be a little bit cautious here because I'm subtracting. So 4y, take away negative 2y. That subtracting a negative is going to make that a positive. And so it's going to allow me to have positive 6y, so plus 6y equals, and then again I'm going to have to beware of that negative. 24 take away 6 is going to leave me with 18. So now I'm going to clean this up. I end up with 6y equals 18. And dividing out my 6 on each side, I end up that x is, my bad. I get that y is equal to 3. So now I've solved for one of my two variables. And so I'm not done yet because, of course, we're looking for the point of intersection, and that's an ordered pair. And so now I'm going to go ahead and I'm going to choose either of my original equations or any of the derived equations in order to solve for x. Now, I'm looking at things and I'm thinking that this original guy here, x plus y equals 6, is the simplest way for me to get a value for the x coordinate. And so that's what I'm going to do. I'm going to try to squish that in here, people. So x plus y equals 6, and of course I know that y is equal to 3. So x plus 3 equals 6. So when I solve for that, I get that x is equal to 3 as well. So there I have my x coordinate, my y coordinate. I can make a therefore statement over here about my solution being at 3, 3, and I'm good to go. So what I'd like you to do is to attempt this next question by solving the following system. And I want you to, again, use the elimination method. I've chosen these because I want to see what you can do with them. They're a little bit trickier, but I think that you can do it. So take a minute to try out this example, and then I'll come back and work through it with you. Okay. So let's take a quick look at these equations to decide what the heck to do. So I know that in this case, you know, there's no way of multiplying, like to get my coefficients of beside x the same. There's no way for me to multiply 3 to get 5 or vice versa. So if I were to try and align those, I would need to multiply my x, this whole first equation by 5 to get 15x, and this whole equation over here by 3 to get 15x, to eliminate my x's. Now another thing that I can do is I can also align my y's. So again, I can't multiply 2y, this equation 2y to give me negative 3, and I can't take negative 3 and multiply it to give me 2y. So either way, using either of these equations, I'm going to have to multiply both of them to get the coefficients the same. So it really just depends on whether you like working with bigger numbers or you like working with negatives more. I think I'm going to try to get these y's to be 6's, and I think that'll probably be the simplest solution. But there are certainly other solutions, and if you do this properly, if you chose those other methods, they should also yield you the same solution. So let's do it. So what I'm going to do is I'm going to multiply this first equation by 3, and that will give me 6y. And then I'm going to multiply this second equation by 2, and that will give me, oops, this is not turning out too well, by 2 to give me 6y, well, negative 6y. So I'm going to go ahead and do that. So equation number 1, my new equation is going to be, when I multiply all of that 3 into every part of this equation, I'm going to get 9x plus 6y equals, 3 times 28 gives me 84. And now I'm going to write my new equation number 2 below it. So 2 times 5x gives me 10x. Oops. And then 2 times negative 3y gives me negative 6y. And then 2 times 15 gives me 30. So looking at this, I can see that in order to eliminate my y variable, I need to add these two together because, of course, 6y plus negative 6y will give me 0y. Let's work out the rest. So 9x plus 10x will give me 20x. And then 84 plus 30, 84, 94, 104, 114. And so let's clean this up. So 20x is equal to 114. X is equal to my 114 divided by 20. X is equal to... I just realized I made some really silly mistake, some silly adding mistake. So I'm going to go back, and you probably already like, what the heck is she doing? But here I am. And let's try that again. So let's try that again. So I get 19x. 9 plus 10 is in fact 19. Yes, people. Is equal to 114. And so when I divide out 114 by 19, that gives me a much nicer number. So I get that x is equal to 6. So now I'm at the spot where I can go ahead and I can sub in x equals 6 into either of my original equations. I'm going to choose the first equation, number 1, before I did any multiplying. So I get 3x plus 2y equals 28. So going ahead and subbing in for x, subbing in the 6, and solving for my y, I'm going to find myself another column here. I'm getting 18 plus 2y equals 28. So 2y is going to be the 28 minus 18, which will leave me with 10. And so y is equal to 5. So hopefully you got that your solution was 6, 5. And so I'm going to be assigning you some homework questions to do that will help you to solidify this process, and so that when we come back to class together tomorrow, we can do a few warm-up questions, and then we'll be ready to move on. If you are struggling with this, please feel free to come and see me at lunchtime tomorrow, and we can work through a few more examples so that you can make sense of this concept.